In section 4.3, we're going to talk about the rectangle, the square, and the rhombus. So a rectangle is a parallelogram, so everything that's true about parallelograms are true about rectangles. What do we know about parallelograms? Opposite sides are parallel, opposite angles are congruent, consecutive angles are supplementary. That's true for any type of parallelogram, and it's also true for a rectangle. The only distinction, or the last distinction in the definition of a rectangle, is that a rectangle is a parallelogram, but it has, notice, a right angle. Now the truth is, it actually has 4 right angles, but we only have to prove that one of them is a right angle. Why? Because in a parallelogram, consecutive or adjacent angles are supplementary. So if that's 90, that one's going to be 90. And if that one's 90, that one's going to be 90 because they need to be supplementary. And also opposite angles are supplementary. Opposite angles are congruent. So we just have to prove it has one 90-degree angle, and that would mean that all 4 angles are 90 degrees. So then we have some other corollaries. Opposite sides of a parallelogram are congruent. Well, we know that because so the opposite sides of a rectangle are going to be congruent. Consecutive angles of a parallelogram are supplementary, which means consecutive angles of a rectangle are going to be supplementary. All angles of a rectangle are right angles. Here's our new definition. If it has one right angle, all 4 are going to be right angles. And here's something new. The diagonals of a rectangle are congruent. So the diagonals of any parallelogram bisect each other. So for any parallelogram, the diagonals bisect each other. But for a rectangle, not only do the diagonals bisect each other, but the diagonals are congruent. The diagonal lengths are the same. And you can kind of think of that because we have, that would be one triangle, and that would be the other triangle, and they have right angles, the upper triangle and the lower triangle, the upper triangle and the lower triangle, and they have side, 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 so they're congruent. So the diagonals of a rectangle are congruent. Now, this book introduces square right after the rectangle. So let's just kind of put this in order here. We have parallelogram. And underneath parallelogram, we have, parallelogram comes under quadrilateral. We have rectangle. And you know what? A square is a very special type of rectangle. A square is actually a rectangle. So everything that's true about a rectangle, having 4 90-degree angles, and the diagonals being congruent, is also true of the square. But the square is a rectangle that has 2 congruent adjacent sides, which means this side is congruent with this side. Well, since it's a parallelogram, if that side has that measure, then this side has that measure. So really, a square is a rectangle that has 4 congruent sides. So because it's a rectangle, it's going to have the 90-degree angle. But it has the additional requirement that all 4 sides are congruent. So all the sides of a square are congruent. So what do we know about diagonals? Here we know that the diagonals will bisect each other. Because it's a parallelogram. Here we know that the diagonals will be congruent because it's a rectangle. And here's something interesting. The diagonals of a square are perpendicular. And I'll get into the reason why in a moment, but not only do they bisect each other, not only are the diagonals congruent, but the diagonals are also perpendicular to each other in a square. So in a moment they're going to show that the diagonals are also perpendicular. So the square takes a lot of its characteristics from a parallelogram, some from a rectangle, and then it has some of its own. But now I want to introduce the rhombus. So we have parallelogram, and under parallelogram we have rectangles. Rectangles have 90-degree angles. Okay, and we know that the square is a type of rectangle. Under parallelogram, there's another characteristic, and that's called rhombus. A rhombus is a parallelogram with two congruent adjacent sides. Rhombus. The rectangle has to do with the 90-degree angles. The rhombus has to do with the congruent sides. All four sides are congruent. So this is very interesting. A square is a rectangle, but a square is also a rhombus. So everything that's true of a rectangle will be true of a square. Everything that's true of a rhombus will be true of a square. So a square is a very interesting shape. So for any rhombus, a rhombus is a parallelogram. Opposite sides are parallel. Everything about the consecutive angles being supplementary, diagonals bisecting each other, but they have two congruent adjacent sides. So if that's one tick, then that one's one tick. If that's one tick, then that's one tick. All four sides of a rhombus are congruent, which happens to be true of a square. The square has four sides congruent and the 90-degree angles. Here's a rhombus. All four sides are congruent, but here the angles are not 90 degrees. So all the sides of a rhombus are congruent, and the diagonals of a rhombus are perpendicular. That's why we knew the diagonals of a square are perpendicular. Here's one diagonal, here's another. The diagonals bisect each other because they're parallelograms, but the diagonals meet at perpendicular lines because they're a rhombus. And that's why that condition is also true for a square. So a square is a rectangle that has some properties of a rhombus, or you can think of a square as a rhombus that has the properties of a rectangle as well. So here's an alternate definition of a square. A square is a rhombus whose adjacent sides form right angles. And the diagonals of a rhombus or a square are perpendicular bisectors of each other. We're putting both conditions together. Rather than saying they're perpendicular and they bisect, we're going to call them perpendicular bisectors of each other. That takes care of both categories at the same time. Perpendicular bisectors of each other. And we just end once again with the Pythagorean theorem, because when we're talking about rectangles that have 90-degree angles, or when we're talking about squares that have 90-degree triangles, you may use the Pythagorean theorem to find the length of a diagonal. Or you may be given a diagonal and asked to find the length of one of the sides. So we're just going to revisit the Pythagorean theorem. The longest side, c squared, is a squared plus b squared. So what's the length of the hypotenuse of this right triangle? The Pythagorean theorem is only true for right triangles. So c squared is going to equal a squared plus b squared. So c squared is going to equal 64 plus 36. So c squared was going to equal 100. And so if I want to get c by itself, I'm going to take the square root of both sides. So I get that c is 10. This is a side length of 10.